Hello and welcome to U substitution part 2, where we're going to look at a couple more problems and then what happens if you have a definite integral instead of an indefinite integral. So pause the video here and try these first 3 problems out, and then I'll come back and I will solve them all. Okay, so for this first one, again, the big thing with U sub is figure out what's in your parentheses. So I'm going to consider U to be equal to 4x minus 3, which means du dx is equal to just 4. So dx is then equal to du over 4. When we plug this back in, this now becomes the integral of the cosine of just u, du. And so the integral, or the antiderivative of cosine of u, is sine of u plus c. The last thing we want to do is actually plug this back in, and this becomes sine of 4x minus 3. Notice u substitution is really good to deal with this because we have this constant, right? You technically could probably do this without u substitution just because you're trying to eliminate the 4, but understand that this is technically the correct way to do it. For the next one, our goal again is to try to simplify this as much as possible. In this case, if we're looking at what's in the parentheses, we see that the secant is what's in the parentheses, and that kind of tells us we want to use that as our u. So we use u is equal to secant of x, which means du dx is equal to secant x tangent x, and so dx is just du over that, which means that when we plug this back in, we're going to divide out that secant tangent, which is great because we're trying to cancel that out. That's way too much multiplication. This becomes the integral of sine of u du. And now to take the antiderivative of sine, that's just going to give us negative cosine of u plus c. And then the last piece is just negative cosine of the secant of x. Weird problem to think about because it's like cosine of secant, right? They're kind of, they're not inverses of each other, right? But one's cosine and one's 1 over cosine. All right, this last one's a little bit trickier. When I first looked at this, I was really trying to figure out what do we really want to get rid of, right? We don't necessarily want to use the secant because using the secant as our u, its derivative is secant tangent. And so that gets rid of one of the tangents, but not the other one, right? And you kind of have that thing where you're doing the derivative of u, but it's also u, right? It's u times tangent. So instead I thought, hey, let's use the tangent. So if we say tangent of x is equal to u, then du dx is equal to secant squared of x, which means that du over secant squared of x is equal to dx. So now we sub in our u. This becomes the integral of u squared, and then this secant squared is going to cancel out with that dx. It's just du. This will then give us 1/3 u cubed plus c. And now all we have to do is say, hey, well, what's going on with u? U is really tangent. So this becomes 1/3 the tangent cubed of x plus c. Remember to make sure that you're applying that cube to the tangent. You could technically, though it's not as proper form, write it with like 1/3 and then tangent of x, that whole thing cubed plus c, but make sure you're not doing this, right? This would be illegal. 1/3 tangent x cubed plus 3. Now that looks like the cube is applying to the x. That is no good. All right, well, what if we had bounds? So in this problem, we have bounds. We're still going to have to do u sub, right? So this is a definite integral, but we have to figure out which one are we going to use as u. Is it going to be the x cubed minus 4x or the 3x squared minus 4? We can pretty clearly see that 3x squared minus 4 is the derivative of x cubed minus 4x. So let's let u equal x cubed minus 4x. That means that du dx is equal to 3x squared minus 4, or dx is just equal to du divided by 3x squared minus 4. When we plug those in, we now get the integral of the square root of u du. What about these bounds, right? To figure out what those values are going to be, we actually have to look at the new u. So we'll figure out essentially u of 2 and u of 3, meaning we're going to plug 2 in for x and figure what u value we get out. So u would be equal to 2 cubed minus 4 times 2, which is 8 minus 8, or 0. And then we're going to do the same thing, but with 3. So u equals 3 cubed minus 4 times 3, or 27 minus 12, which is 15. The great part about this is that now we're not going to have to go back to those bounds of 2 and 3 and plug them into the new function. We're actually able to just integrate with these new bounds and use that for our new quantity. So we say, okay, well, what's the antiderivative of square root of u? That would be u to the 3 halves. And of course, we have to multiply by the reciprocal of that power, which is 2/3. Now, again, there's no plus c here because this is a definite integral, right? It is bounded. But now, instead of replacing u, which we had to do in the indefinite integrals, we're actually able to just plug these bounds of 0 and 15 in. So 15 is the upper limit, 0 is the lower limit. From here, this just looks like 2/3 times 15 to the 3 halves minus 2/3 times 0 to the 3 halves. We don't really care about the 0 to the 3 halves because, 0. So our final answer ends up being this: 2/3 times 15 to the 3 halves, which is a really gross irrational number, but none we have to worry about. So to summarize, when we have a definite integral, the first thing we have to do is still do our u sub, right? We figure out, we plug it back in. But to find the new bounds, we have to plug those original x values into the function we used for u. And then we get our new bounds for our integral. And from there, all we have to do is integrate and plug in those new bounds. There's no plugging back in the old function. Okay, pause the video here and try these two problems out. So for the first one, this one is really trying to tell us that this is the u sub we're going to want to, this is the u we're going to want to use. It's in parentheses already, and we're raising it to the 3rd power. There's no way we'd really use x here. We're just going to use u equals x squared plus 4. This tells us du dx is equal to 2x, or dx is equal to du over 2x. When we plug this in, we now have a 1/2, canceling out that x, and then u cubed du. To figure out the bounds, we're going to plug 0 in for x here. And so this looks like 0 equals u squared plus 4, or the lower bound being 4. And then we plug again 2 in, and so it looks like 0 equals 2 squared plus 4, which equals 8. So now we're going to integrate. And so we're going to reverse power rule, which means this cube now goes to a 4th. And we're going to have a 1/4 out front to cancel it out. However, we also have that 1/2. And so this becomes just a 1/8 u to the 4th. We're going to integrate that from 4 to, or we're going to evaluate that from 4 to 8. So now we just have to plug our bounds in. This becomes 1/8 times 8 to the 4th minus 1/8 times 4 to the 4th. I think this is something we could do without a calculator, but I don't think they're going to ask you to do that. And it's really not that bad to do with a calculator. Though probably we wouldn't even do all these steps if we had a calculator. But we'll say for now, this is our final answer. For the second one, this is one where we're just trying to get rid of this. We don't want to integrate with the 7x. So we're going to say u is equal to 7x. A lot of times you might even just say, oh, well, this is going to become 5/7 when I do it and just plug in the bounds. But let's say, for example, you do use u substitution here. That means du dx is equal to 7, or dx is equal to du over 7. This now becomes the integral of 5/7 times sine of u du. And then all we have to do is figure out our new bounds. If we plug 0 in, we're going to get a 0 out. So that's not too bad. we plug the pi over 14 in, pi over 14 times 7 just becomes pi over 2. So now all we have to do is integrate. We say, hey, what's the antiderivative sine of u? That's negative cosine of u. And then, of course, that 5/7 still there. 0 is the lower bound, pi over 2 is the upper bound. And so now we just have to plug these in. This becomes negative 5/7 times cosine of pi over 2 minus a negative, so plus 5/7 times the cosine of 0. Well, cosine of pi over 2 is just 0. And then cosine of 0 is 1. And so this becomes 0 plus 5/7, or our final answer of 5/7. Okay, in the final video of USUB, we're going to look at a couple harder problems. This one, I really wanted to focus on the change of bounds because that's not something we've hit a whole lot on, but we are going to hit just some other problems dealing with USUB in general. If you have any questions, as always, feel free to reach out. Bye-bye.